Good morning, everybody. Here is a quick little essential only tutorial on covalent bonding if you find this topic a bit overwhelming. Step 1, pay attention to these diagrams up here. There's your Lewis dot diagram for everything in that column. If you see a number like -1, which is also in your textbook, that's it. It's missing one electron. Do not attempt to draw iodine or bromine because you can only do the Lewis dots up to element 21. These come from rows that have far more than 8 electrons in the outer shell. So iodine here, iodine, you still treat it as a -1, exactly like fluorine. So I'm going to do one of these below. I'll do iodine. So I'll slide down a little bit. So iodine has all but 1. So I fill in all of them but 1. I put the empty to the outside because it's easier. That's something I need to fix here. It worked for fluorine, but I really prefer the empties to the outside, and I'll show you why in a minute. So now, iodine wants 1. Why does it want 1? Because what are you going to do? Look at the list up top here, from boron over to fluorine. It's a little hard to see, but missing 1, missing 2, missing 3. At the point you reach carbon, it's missing 4, has 4. So the ones that have more than half will want to gain. So he's going to want 1, he's going to want 1. So this iodine says, you give me 1. And the other iodine says, no, you give me 1. And they drag to the center. And at this point, you can circle the shared zone. And there's iodine. Well, what's bromine going to look like? It's going to look exactly the same because it has the same -1. What's chlorine going to look like? It's going to look exactly the same because it says -1. So this entire first row, I just descended straight down, and every last one of these is going to look like that diagram there. Let's try bromine together. If I freehand it, I just do this. That's what most other teachers do, and that's what I don't like. It looks really messy, and to me, this method I've chosen, shown by fluorine, makes it a lot clearer, especially for me if I'm marking 90, and for you if you're trying to understand. That's why Kaladi notation I put in the empties. So here again, you could just go like this. And while I would circle them both, like my example with fluorine, some teachers do this. I just find that when you're learning it, seeing that written down as your example is not nearly as clean as this one over here showing fluorine. Okay? Let's try a harder one. Let's do oxygen, which isn't on this page. If we look at oxygen up here, it says -2. So if I draw an oxygen, if I make it a little bit neater, I'm going to do -2. And I just told you oxygen's going to be O2. It's right here. They expect you to know that in grade 10. In grade 10 academic, you're supposed to know it. In grade 10 applied, heck, in grade that it needs to be 2. But eventually they expect you to sort of know this. I draw a second oxygen. There's my empties according to Collodi notation. And I want to show the bonding. He wants to, so he'll share 2. Wants to, so they'll share 2. And you're done. And if you want to do anything more complicated, we could try CO2. Ah, come on. Give me the drawing. Where did it go? I got it right here. See? 4 filled, 4 empty. What's it going to want to do? We have to tell you at this point in time. We have to say, oh, it's going to be a covalent bond. Now, oxygen wants to. It's missing 2. So if I'm going to form CO2, I'm going to put an oxygen here. And I'm going to put an oxygen there. This oxygen says, my dear, I would like to have 2 electrons. Would you share 2 with me? And oxygen puts its 2 on the table. Well, carbon really wants 4. So you go, okay, yeah, no problem. Toots here. How you going to do? Yo, there you go. Because it's a New York carbon atom. Okay? And then he goes, oh, you got a sister. Oh, twins, yeah. And he goes, yo, there you go. Hey, come back to the Big Apple anytime. And she goes, well, that's very nice of you. There you go. And now they've shared. Okay? And then you can go, yippee, she's done, and he's done. And that's about as hard as it can get. All right, so hopefully that helps. What a lot of textbooks will draw is this. And they won't even bother with the color. And they will show the covalent bond like that. And I just find it's not good for teaching. Once you know what you're doing, maybe that's fine for you. You go, huh, and I even screwed this up because I should have had that. And how do I know? 2, 4, 8. 2, 4, 8. 4, 4, oops. This can't be there either. So that's a way of drawing, just using like, oh, I'm just quick drafting. And it doesn't really work for me. It doesn't make it clear what's going on. And of course, some teachers will go like this. And I just find that for teaching purposes, these diagrams are so god-awful looking that they don't help a student learn. And that's why I like my fancy one here with fluorine to really try to make it evident what is going on there. So if we try one more example together. And I want you to do carbon tetrahydride. A carbon bonded to 4 hydrogens. And if we're going to bond to 4 things, it's best to just sort of assume it's going to be carried around like that, that we need the 4 spots around, okay? Structurally, carbon tetrahydride, or CH4, looks like this, right? I'm going to put my hydrogens in. I'm going to put a hydrogen here. Now, hydrogen has 1 electron. Should I put it here or down here? It doesn't matter, but I like to pair the, because I tend to crowd my diagrams, pair the full with the empty. There's going to be 4 hydrogens bond. So you see what I mean here? This is where I get crowded in this spot. So this hydrogen goes, hey, I'll share with you. Passes one forward. And because I'm cramped, I don't get a nice clean draw there. And he goes, he shared back. Now that hydrogen says, woohoo, I'm done. But the carbon can't say he's done yet. He only managed to share one more. So it's going to repeat itself in every direction. Carbon over here is going to say, hey, how about I lend you one? And this hydrogen will say, then I'll lend you one back. And now we've got 2 shares for the carbon. And you can complete going around the clock dial and you'll have CH4. If you can do CH4, then you can do NH3. It'll be It'll be 3 of them. I've set it up on the back page. And it's the same thing. Nitrogen wants 3, hydrogen only wants 1, so you're going to have to do the sharing 3 times in a row to help nitrogen out. So hopefully this gives you a little bit more to work on. For those of you that are still maybe struggling with this, which one would you need to be able to demonstrate in grade 9? Fluorine. That's it. It's good enough for grade 9.